Hi and welcome to Gaffy's Grinds. This is our first video in our Back to Basics series or our Back to Basics playlist on titration calculations. Now, before we begin looking at exam questions, what we want to do here is we want to try and build up your ability to do the unit conversions that you're going to need to do in the questions. So instead of us jumping into a full question with difficult language that you see in the exam questions, we're just going to scale it back and look at the basic types of calculations that you have to be able to do. Now, this is a good reminder if it's been a while since you've done these, or if you've been stuck into the middle of a load of titrations and you're still not getting it, it's a good idea just to go back to the start and figure out what little bits are you missing. Okay, so in this video, we're going to do a series of examples of different types of calculations where I'm going to do some where you watch as I do them, and then we're going to do some together. I'm going to kind of talk you through some of them, and finally, then I'm going to ask you to do them at the end. It's very important that you're active during this video, so you shouldn't be just watching me all the time to see my examples. You should be getting stuck in. So you're going to need a calculator and you're going to need your periodic table. All right, the first type of calculation you're going to be able to do is to convert between centimeters cubed and liters. I find in all the titrations questions, it helps if you just convert all the volumes to liters as soon as possible. So this is something you have to get quite good at, quite automatic at. All right, so I'm going to show you how I would do this one here. Convert 25 centimeters cubed to liters. This is a very common quantity because this is usually the quantity that we put into the conical flask. All right, so planning out, what do we have to do here? We're starting with centimeters cubed and we have to convert to liters. Okay, a very common conversion. All right, so how would I advise you to start doing this? I start doing this by writing down what you have. You have 25 centimeters cubed, 25 cm cubed. Okay, and what we want to do is we want to use a conversion factor, which is a fraction like this. So we're going to times what we have by a fraction. And remember, a fraction has a numerator and a denominator. And we always want to make sure that we want to cancel out this unit because we don't want centimeters cubed anymore. We want to end up with liters. So to cancel out this unit, we put it in the denominator of our conversion factor, because once it's in the denominator, we can cancel with this numerator here. So that cancels out centimeters cubed. And obviously the other thing we want in our conversion factor is liters. And the next thing we got to know is, well, we got to know what's the relationship between liters and centimeters cubed. This is a number you have to remember. 1 liter equals 1,000 centimeters cubed. Okay, so when we do this sum out here on our calculator, obviously we're going to be left with liters in our answer because that's the only unit that hasn't been cancelled out. And that's good because that's what we wanted to convert to. Okay, so what we're going to do is get a calculator now, and you're going to do 25 times a fraction 1 over 1,000. And those of you who are good at maths will know that this is the same as dividing 25 by 1,000. But this is what you're actually doing when you're dividing 25 by 1,000. So when you do this, you should get 0.025. Now, there's another way of thinking about this. I'm going to give you a shortcut to think about this. If you have 25 centimeters cubed, 25, well, we know that this number really is 25.0, okay? And if you think about it, what you're doing is you're essentially dividing by 1,000 here. 25 times 1 over 1,000 is the same as saying 25 divided by 1,000. And you learned in first year maths that if you wanted to divide by 1,000, what we would do is move the decimal place 1, 2, 3 spaces to the left. And that means we need to stick an extra 0 in. So this is a good, quick way of doing this. If you can remember this and get it right all the time, you can do this really quickly by moving the decimal place 3 places. Okay, but I don't want you to do that right now. Okay, I want you to practice using this method while we're doing this here. Okay, once you get really good at it, then you can do the decimal point method. All right, so we're going to do a we do now. This means that I'm going to kind of step you through it. Okay, so a reminder, what do we need to do? The first thing we're going to do is write down what we know. We know we have 25 centimeters cubed. I want you to plan it out. What exactly do we have to do? Okay, so pause the video and plan out the conversion here. It's very simple. Okay, so planning it out, we know we want to go from cm cubed and we want to go to liters. That's how we plan it out. This is what we have. This is what we want. Okay, so the next thing we're going to do is write down what we have. Okay, so what we have is 20.5 cm cubed. We're then going to use a conversion factor where we multiply this by a fraction, conversion factor, and we're going to get equals, and we want what unit in our answer? We want liters. So we want liters to be over here. That means we need to set this up so that we leave liters. All right, so what I want you to do is write this out, and then I want you to fill in just units. Forget numbers, just units on the top and bottom of this conversion factor. Do that now, please. Okay, so you should pause the video and you should do this, please, while I ask. All right, so we want centimeters cubed to cancel, which means we're going to put it in the denominator here like that. And then we want liters to be left on the top. All right, the next thing is we need the number relationship between centimeters cubed and liters. So I'm going to cover it over from before. What is the relationship here? Pause the video and write in the numbers. Okay, what you should have said is for every 1 liter, we have 1,000 centimeters cubed. So 20.5 times 1 over 1,000. Pause the video and get the answer in liters now. Okay, what you should have got here is 0.0205 liters. All right, so that is how we convert centimeters cubed to liters. And obviously, hopefully, you guys could work out how could we do it if we needed to go the other way. If we had liters and we wanted to go to centimeters cubed, again, if we use the conversion factor, again, you've got to figure out which unit is on the top, which unit is on the bottom. So I know we've done this before. I have lots of videos doing this method before. So hopefully you guys will be able to do that. You're going to have to do one of them or two of them in this here. Okay, so these are for you to do. So you do the whole lot of these 4 without any help. So pause the video and you're doing these now. Okay, and you should only be playing if you have completed those. And what I'm going to do now is I'm going to show you the answers that you should have. Okay, so for them 1 to 4, these are your answers. Okay, so well done if you got those right. The only place I could really see it going wrong there is on 3 or 4 because they ask you to work backwards. So I'm just going to show you one of them just in case they went wrong on you. Planning these out, we want to go from liters to cm cubed. That's the plan. Okay, so again, you just write down what you have. We had 1.24 liters, and we're timesing it by a conversion factor, which gives us, so we want to get rid of that and leave us with this. So we need centimeters cubed over here in our answer, which means we want to go between liters and centimeters cubed on this conversion factor. So what should we put on the bottom? So pause the video now if you didn't get this right and work your way through this, please. Okay, so obviously we want liters to cancel there. So we're going to put liters on the bottom and they cancel. And that means we want cm cubed on the top. So our relationship this time is because centimeters cubed is on the top, it's 1,000 on the top and 1 on the bottom. So it's 1.24 times 1,000 over 1. And that'll give you 1,240 centimeters cubed. Now you see what I'm doing with the units. The biggest mistake I see my students make is they watch me doing this and it makes sense and they see the units being done, but then when they do it, they don't put the units in. They just try and put the numbers in, and then they have no idea what's supposed to go on the top, what's supposed to go on the bottom, and they get lost and they don't plan it out like I'm planning it out here. And again, this is just the best logical way of thinking through your calculations. I mean, this makes sure you don't get lost. Whereas if you jump in, you try and half do it, you try and use a half a method of what I'm showing you, and you're never going to be able to do these titration calculations. I know some people use formulas to work between moles and mass and grams, but that doesn't help you understand and think through the problems any better. Okay, and formulas really just hide the maths. And what that means is like you're just plugging numbers into formula. You don't really understand what you're doing. With this should, if you do this properly, this should help you understand what you're actually doing. All right, so that's the first calculation, going between centimeters cubed and liters. Let's now do this one here, going from moles to grams. Okay, so different type of calculation, but one we need to be very good at. Okay, and I'm going to do the first one, show you how to do it. So planning it out, I always plan it out. Look what I'm doing. I'm going from moles, because it says convert 2 moles of this substance to grams. So I'm going from moles of Na2CO3 to grams of Na2CO3. That's what I need to do. Okay. So I know I've got 2 moles of Na2CO3. So I'm going to go ahead and write that. 2 mole of Na2CO3. And now I need a conversion factor that goes between moles of Na2CO3 and grams of Na2CO3. Remember, I want this to cancel and leave me with this in my answer. So over here, after my equal sign, I need to finish up with grams of Na2CO3. And I need a number here, obviously. Okay. So I'll have a conversion factor here. I'm going to times this by a fraction. And of course, I need this to cancel. So mole of Na2CO3 has to cancel. So I need to put it on the bottom in the numerator, sorry, in the denominator here. Mole of Na2CO3. Cancel that out. And that means I'm going to put grams of Na2CO3 on the top here. Now, of course, this is the only unit left, which makes sense because that's what my answer is in over here. There's no more moles of Na2CO3. So the next thing is, what's the relationship between moles of Na2CO3 and grams of Na2CO3? In other words, how many grams is 1 mole? So I'm going to set the moles to 1. How many grams is that? Well, of course, this substance determines how many grams it is. Na2CO3, you've got to work out the molar mass. So when I add them up, the masses of 2 sodium atoms, a carbon atom, and 3 oxygen atoms. Again, molar mass, I'm assuming you guys know how to do that. If you don't, there's video on that in the mole section or in the stoichiometry section. This here is 106 grams in 1 mole. So I'm going to go ahead and do that now. 2 times 106 over 1. I'm getting 2 moles has a mass or has 212 grams of Na2CO3. Okay, so again, see, I know I'm definitely right because look at the units I'm leaving. They're the units that are left. Again, if you skip that, you get sloppy with the units, then you're going to get lost. Okay, so don't skip any steps. Get used to doing the whole lot. I've been doing this for 15 years and I still do this. Okay. All right, so let's go and have a look now at this one. Okay. So we got 0.5 moles of Na2CO3. We want to go to grams. I want you to pause the video and plan out what is it that you're going to do. Pause the video and do that now. All right, so we're going from moles of Na2CO3 to grams of Na2CO3. Good, well done. Okay, and the next thing that I want you to do is I want you to start working out your problem. Some of you should be able to pause the video and do what I just did in the last example, get the answer here. Okay, so hopefully you were able to pause the video. And again, remember what I say, lose the crutch. Don't be just watching me doing it. As soon as you can, get rid of me, okay? You need to start doing this by yourself. Okay, so begin by writing down what you know. You know you've got 0.5 mole and the substance is Na2CO3. Right, I'm going to skip and leave a blank here. What do I want my answer to be in over here? So writing down over here on the right-hand side, what units will my answer be in? Write down your answer, do that now. Okay, so my answer should be in units of grams of Na2CO3, which means my conversion factor, I need to get rid of moles of Na2CO3. So what will I do on my conversion factor here? Pause the video and put something on top and bottom of this fraction. Okay, so obviously, if we want to get rid of moles of Na2CO3, it's in the numerator, put it in the denominator down here, moles Na2CO3, and then this is grams of Na2CO3 up here. And my relationship is the same as the one I did. For every 1 mole, there is 106 grams of sodium carbonate. Go ahead, get your answer. Pause the video now and work out how many grams of Na2CO3 is that. Okay, so what you should have got here is 53. Well done if you got that correct. Okay, so here are some problems for you to try. Pause the video and do that now. Okay, a reminder, look at the last one carefully because it asks you to go the opposite direction. You've got grams and you've got to go to moles. Shouldn't cause too much problems. If you can go one way, you can go the other way. Just use the unit analysis. Look at the units. Okay, so here are the answers to those 3 questions. Hopefully you got them all right and you're building your confidence. Again, the titration calculations just ask you to put all these little bits together. All right, but it's very important that you have all the little bits first. Okay, I'm just going to do this one just in case. I'm going to do it really quickly here. We've got 0.032 grams of NaOH, and we want to go to moles of NaOH. So we times it by a conversion factor, and we want grams of NaOH to cancel. So we'll put that down here, grams of NaOH. And then we want moles of Na, of course that cancels, so we want moles of NaOH in our numerator. And of course that would leave us with an answer that's in moles of NaOH, because the grams of NaOH have all been cancelled out. Okay, so the next thing is for every 1 mole, so it's 1 on the top this time, how many grams of NaOH do we have? So you should have your periodic table to work out the molar masses of NaOH. You should get 40. So then you just do 0.032 times 1 over 40. And that gives me 8 by 10 to the minus 4. So 8 times 10 to the minus 4. Again, a very common calculation to go between grams and moles. You need to be able to do that very quickly, very easily. All right, we're stepping up the difficulty now, okay? We're introducing concentration here. All right, so let's say we have a 2 molar solution. We want to find the number of moles in 0.25 liters of a 2 molar solution, 2 mole per liter. Okay, so that's the first thing to note, is that 2 mole per liter can also be called 2 molar. We're going to see that in some of the future questions where they don't tell us mole per liter. We're just told 2m, or we're told 0.5m. And again, that's something that you need to know, that moles per liter is equal to m, or molar. All right, so what do we know? We know we have 2 mole per liter, and we want to find the number of moles in 0.25 liters. So planning out this question, what are we going from? Well, we're going from a number of moles per liter of NaOH. That's what we're starting with. That's what we already know. And we want to find just how many moles are in 0.25 liters. 0.25 liters. Okay. So moles of NaOH per liter to moles of NaOH per 0.25 liters. Okay. All right. So what do we do here? Well, we write down that we've got 2 moles per liter solution per liter, but we don't have a full liter. We have 0.25 liters. So that's the number I'm going to put in here, 0.25. All right. And we should then get a number of moles. Sorry, I'm going to go back on myself here for a second. We want to go from moles of NaOH per liter to just a number of moles. That's what it's asking us to find, calculate a number of moles. Okay, so we're just going to go to moles of NaOH. All right, so how do we do this then? Well, let's write down what we have. We have a 2 mole per liter solution. So we have 2 moles of NaOH in every liter. That's literally what this means, 2 moles in every liter per liter. But we don't have a full liter, we only have 0.25 liters. So let's times it by the number of liters we have, 0.25 liters. The liters, of course, cancel out because this here is a denominator and this here is a numerator. So liters over liters is just cancelled out. And you're left with moles of NaOH, which is what we wanted in our answer, calculate the number of moles. Okay, so when we do this, I'm going to go ahead and stick it in the calculator. You've got 2.25, and the answer I'm getting is 0.5 moles of NaOH. Now, another thing to do is to ask yourself as you go along, is this logical? Okay, 0.5 moles. Well, it's less than the number of moles we should have in every liter. We should have 2 moles in every liter, and I have less than that. Did I have less than a liter? Yes, I did. I had only a quarter of a liter. So it's right that the number should go down from 2 moles per liter to 0.5 moles because I didn't have a full liter. Okay, so the number should be less. So again, just using logic to make sure you're not going off. It should be pretty obvious if you've done something very wrong. All right, we're going to do this one together, okay? So calculate the number of moles in a 0.019 liter solution of 1.2 molar HCl. Okay, so again, what are we going to do here? Pause the video and write down, what are we converting? What's the plan? Okay, so just in terms of units, the plan here is to go from molar, which is moles of HCl per liter, and we're going to go to just how many moles of HCl. Okay, so we don't have liter. We want to find how many moles is in a different amount, not in a liter. Okay, all right. So again, now that we've done that, you should be able to pause the video and have a go at this calculation. Do that now, please. All right, so again, begin by writing down what we know. We know we have 1.2 mole per liter solution of HCl. Okay, and what do we want our answer to be in? Well, we want our answer to be in some amount of moles of HCl. So what do we want to cancel? We want to cancel the liters, don't we? So how can we cancel the liters here? Pause the video and finish this conversion. Well, to get liters to cancel here, I need to put liters in the numerator here. So times it by a number of liters. How many liters should I go? Okay, well, it's the number that we used, 0.019. So pause the video and work out how many moles we used here. Times 0.019. All right, before you write down your answer, check, is it logical? Okay, if we should have 1.2 moles for every liter, and we used a lot less than a liter, this number is a lot less than a liter, then we should have a lot less than this number of moles used. Do we? Well, the answer I'm getting is 0.028. Sorry, 0.0228 mole of HCl. Mole of HCl. So yeah, that is a lot less than that number over there, and that makes sense because we did not use a full liter. Okay, so if we used a full liter, we would have used 1.2 moles, but we used only 0.019 liters. So it should make sense that that number is getting smaller. Again, these are the things you want to think about because they give you a better idea if you got them right. Okay, right, and this time you have one extra step to do because this is not in liters yet. Okay, so it says calculate the number of moles if you have a 0.9 molar solution, which we know means 0.9 moles per liter, and the solution is KOH, and we have 25 cm cubed of it, so we need that to be in liters. Okay, so what I want you to do is I want you to pause the video and plan out your problem. What are we trying to do? All right, so what we want to do is we want to go from moles per liter of KOH, and we want to convert. What does it ask us to find? Calculate the number of moles. So we want to find the moles of KOH. All right, now this is the quantity we used. So we need to think about how do we get that into liters. You can do this rough work first, or if you want, you can do it on a calculator, or you can do the decimal method if you're confident with that. But either way, we've got to go from moles of KOH per liter to moles of KOH. Again, it's very similar to the previous one, only it's got this in centimeters cubed. But you should be able to solve that problem from what we did earlier, converting liters to centimeters cubed to liters, and now the bits that we've just done in this section here. So pause the video and work this out. All right, so what I'm going to do is I'm going to work through it now. Hopefully you got this right. 0.9 mole of KOH per liter. That's what 0.9 molar means, per liter. And we want liters to cancel, of course. We want to get rid of that liter, so we're left with moles. So to cancel that liters, we're going to have to multiply by a volume in liters. Now, we don't have a volume in liters, but we have a volume in centimeters cubed. So you can do this rough work, 25 cm cubed times by, well, we want cm cubed and liters, and we want cm cubed to cancel. And we know that we've got 1 liter for 1,000 cm cubed. So when you do that, 25 times 1 over 1,000, you should get 0.025. And some of you may be able to do that in your head. So 0.025 liters. So let's go ahead and work out how many moles we have. Of course, our liters have cancelled now, and we're left with moles of KOH, which is what we wanted. How many moles? Equals some amount of moles of KOH. Let's pause the video and work that out now. And the answer I'm getting is 0.0225 moles of KOH. Okay, so well done if you got that right. I think we're ready for you guys to practice a few of those. The first two should be pretty straightforward. They're like the ones we did so far. And then the third and fourth one ask you to work backwards. Okay, so pause the video and do those now, please. Okay, so you should only be watching if you've had a go at these. All right, make sure you don't give up when these get hard, because this is where we're really getting into the stuff that you have to do in the titration. This is the basics of those calculations. All right, here are the answers. Well done if you got those right. And if you had any problems with those, I suggest you rewind them. But what I might do, rewind the video and find out, watch them again, how to do them. I am going to do one of the last ones. I'm going to do number 4 here, just because it's slightly different. It says calculate the molarity. So that's molarity means moles per liter of a solution that contains 0.5 moles of HCl in 700 centimeters cubed. So straight away, I don't like centimeters cubed. I want us to change that to liters. So again, if you didn't do that, let's pause the video and convert to liters now. Okay, so 700 centimeters cubed, I know at this stage that is 0.7 liters. Now, if you don't know how to do that in your head, you do it slowly, step by step, how we showed you already. Okay, so let's plan this out. So this is question 4. What are we doing here? We're calculating the molarity. So we don't know the molarity. That's what we want our answer to be in, moles per liter of HCl, moles of HCl per liter. But what we're starting with is we have moles. We have a certain amount of moles per 700, so 0.7 liters. Okay, so actually what we need to do here is just use moles per liter. All right, because we have a number of moles and now we have a number of liters. So we literally put the moles over the liters, because that's what we want our units to be, our final answer to be in. So this is actually pretty straightforward. There's not too many steps here. We just put 0.5 moles. That's what we're starting with. And we know that's in 0.7 liters. Okay, so look at our units are actually right here, moles per liter. So there's no conversion here. You just put the number of moles you have over the numbers of liters you have, and that'll give you your answer in moles per liter. So what I'm going to do here is 0.5 divided by 0.7, and that gives me 5 over 7, or 0.714, and that is moles over liters. Okay, so well done if you got that right. That should make sense if you have 0.5 moles in 0.7 liters. Well, if we make this a full liter, that's putting liters up by a bit. Well, then this should go up by a bit. Okay, obviously to go from 0.7 of a liter up to 1 liter means we're going up by just a little bit, by like 0.3 of a liter. So this should go up as well. Okay, and that's what happens here. 0.5 goes up to 0.714. So again, that's, again, logical, seems right. And these are the ways you need to learn to think when you're doing these calculations. All right, I think we're getting down to the nitty-gritty stuff here. Okay, so do stick with me. We're making it a little bit harder here. It says calculate the molarity of a solution containing 88 grams of NaOH dissolved in 0.5 liters of deionized water. Okay, so thinking about the steps that we're going to do here, we have 88 grams, the substance is NaOH, and we have it in 0.5 liters of water. Okay, so the plan here is we've got grams, that's what we know, of NaOH. And then we want to go to moles of NaOH. And then we want to go to moles over liters of NaOH. That's the plan. Okay, so again, I'm thinking about what I have to do. I need my final answer to be molarity. That's what I have here, molarity, moles over liters. That's what I want my final answer to be in, so that's good. Okay, before that though, I'm starting with grams. I've got to convert to moles and then put the moles over the liters. All right, so what have I got? I've got 88 grams of NaOH. And I want that to cancel. I need to cancel grams of NaOH. So grams of NaOH needs to cancel. To get that to work, I need a conversion factor that has grams of NaOH on the bottom, and then that can cancel with that one there, okay? So both of those are gone, and that leaves me, okay, well, I need moles of NaOH on the top. Okay, so what's the relationship here between moles of NaOH and grams of NaOH? Well, 1 mole equals the molar mass in grams. So the grams for NaOH, calculate the molar mass here. Again, I'm going to get you to pause the video and do that. Okay, nice practice for you. Na is 23, O is 16, H is 1. So that's 40 grams in 1 mole. Okay, so 88 times 1 over 40. 88 times 1 over 40 gives me 2.2 moles. So I have 2.2 moles in the 88 grams. Okay, so 88 grams give me 2.2 moles. That has got me to here. Now I am here. Now I need to have my units in moles per liter. So I've already got the moles in the numerator, moles of NaOH. I've already got moles of NaOH in the numerator. So what I need to do is put liters in the denominator. So liters, and what was my number of liters? Well, it was 0.5. So 0.5. So I'm going to go ahead and calculate this now. It's 2.2 divided by 0.5. And that gives me 4.4. 4.4 molar. Okay, NaOH. Now, apologies, I'm just going to have to move some of these other questions because I'm after taking up more space than I thought I would. So just give me a little minute here to spread these out a little bit. Okay. All right, so back here. Now, again, let's think, is this logical for a second? Well, when I worked out that I had 2.2 moles, remember I worked this out, and then I thought, okay, that was 2.2 moles for 88 grams dissolved in half a liter, less than a liter. So 2.2 grams in less than a liter. Well, if I had the full liter, it should be more than 2.2 grams. And there I have an answer that's more than 2.2, sorry, more than 2.2 moles. I have 4.4 moles per liter here, or 4.4 molar. Okay, all right. So that is, that seems logical again. All right, so let's do a we do here. We're gonna do one where we do it together. All right, so at this stage, what we're gonna do is I am gonna ask you to pause the video and plan out the problem here. What are we gonna do? All right, so the plan here is we're starting with grams of Na2CO3. Sorry, Na2CO3. And we need to finish up with molarity. Okay, so our final answer should be molar Na2CO3. Okay, so what's the step in between? Okay, so I need to go to grams of Na2CO3, and I can't get to molarity, moles per liter, without first getting to moles of Na2CO3. Once I have moles of Na2CO3, I can then find out what the molarity is by using the volume. All right, so pretty straightforward. I think most of you should be able to get started now. If you're confident, let's pause the video and try to do this by ourselves. All right, if you are not or you're struggling here, apologies, I'm going to get you started. Begin by writing down what we know. We know we have 2.445 grams of Na2CO3. And we need those to cancel. We don't want them anymore. We want to go to moles of Na2CO3. Okay, so to make that work, to cancel grams of Na2CO3, I need to put them in the numerator of this fraction, this conversion factor, grams of Na2CO3. And that means that I need moles of Na2CO3 on the top. So the grams are gone. But the next thing I need to think about is, well, what is the relationship between moles and grams? Well, for every 1 mole, I have the molar mass in grams. So again, pause the video, work out the molar mass of Na2CO3. Okay, and the answer we're getting is 106. Okay, 106 grams in 1 mole. And that will give me how many moles? So I'm going to go 2.445 times by, well, I know that 1 mole weighs this, 106 grams for 1 mole, and I have a lot less than that. So I should get a number here that's a lot less than 1 mole, if I'm thinking logically here. 1 over 106. All right, and I do get a number less than 1. I got 0.023, and that's moles of Na2CO3. Okay, that's moles of Na2CO3, which is here. I'm now here, and now I need molar, and I always need to remember what capital M means. It means moles per liter. So to turn moles of Na2CO3 into moles per liter, I need a denominator that has liters on the bottom. And notice what I have now, moles per liter. Good. All right, so how many liters did I have? It wasn't a full liter, it was 0.5. So stick that in here, and my answer will be in molarity. So I'm doing 0.023 divided by 0.5. Okay, and that will give me 0.046 molar. Okay, so well done if you got that. That's 0.046 molar, and that's, of course, Na2CO3. All right, let's do another one. Have another one here together. I think this one is slightly different. Yeah. So it says we have a solution of H2SO4 and it has a concentration of 0.11 molar. So we know this, look, that's our starting point. Calculate the number of grams in 250 cm cubed of the solution. Okay. All right. So planning this out, what do we need to do? All right. So again, I would suggest that you pause the video and think about what do you guys have to do to plan your way through this. All right. The first thing I'm looking at is I'm looking at the cm cubed and I don't like it. All right. So I would advise you at this point to go ahead and convert this to liters first of all. Okay, so you only be playing if you've converted that to liters. Well, straight away, I know that this is 0.25 liters. Okay. All right, so let's think about what do I want my final answer to be? It says calculate the number of grams in 0.25 liters. So my final answer is going to be in grams per liter. Okay, that's what my final answer is in. The units will be grams per liter. And then I'm beginning with moles per liter. I'm beginning with molarity. Okay, molarity, which is moles over liters. Okay, so I'm going to go to moles per liter. I'm going to go to grams in 0.25 of a liter is what I need at the end. Okay. Now, it probably makes sense, if you think about it, to go from moles per liter. And we're not talking about a full liter, we're talking about 0.25. So cancel out your liters and go to moles. Okay. Sorry, cancel out your liters and go to moles. And then from moles, convert to grams. All right. So let's go ahead and try and do this calculation. Now pause the video and have a go at this right now, please. It's H2SO4 is the substance. All right, so first of all, I am writing down, it says 0.11 moles over liters solution, moles per liter. Now I want to find out how many grams there are in 250 or 0.5 liters. Before I can find out how many grams I have, I can find out how many moles I have in 0.25 liters. So I don't want the grams in a full liter. I need to cancel that. I need the grams in a different amount of liters. So I'm going to times it by this different amount of liters to get the moles. Okay, so when I do this, my answer should be in some amount of moles, which is good because that was the middle unit here. Okay, so you're going to pause the video and write down the number of moles here. Sorry, the number of liters, and then calculate the number of moles. Do that now. Okay, so of course I have 0.25 liters. Okay, and when I do that, then I get 0.11 times by 0.25. And of course, if there's 0.11 moles in 1 liter, then I should have less than this in 0.25 liters. So again, thinking about it logically, when you work this out, I'm getting 0.0275, and that is less than 0.11, so that makes sense, and that's moles. And then I want to find out how many grams that would be. Okay, so now we're going to pause the video and convert to grams. And remember what the substance is, it's H2SO4. So I'm just going to zoom out so you can see both at the same time. Okay, so I'm going from moles to grams this time. I need my answer to be in some amount of grams of H2SO4. At the moment, I've got moles of H2SO4. Okay, so pausing the video, I need to cancel my moles of H2SO4. So what I want to do is set up my conversion with moles of H2SO4 here and cancel them out with that one. And then I've got grams of H2SO4 here. All right, so at this stage, I am going to write down that for every 1 mole, I have what I need the molar mass of this. So pausing the video and working that out, please. Okay, the answer I'm getting is 98 grams per mole. So 0.0275 times 98, giving me 2.695. 2.695 grams of H2SO4. So this is the amount of grams of H2SO4 I would have to measure and put into 250 centimeters cubed to make the solution be 0.11 moles per liter. All right, so now you guys should be ready to have a go at these. So working from the examples that we've done, pause the video and work your way through these now, please. All right, and here are your answers. Well done if you got those right. I am going to have a look at number 3 here because it's different. Okay, so it says here, solution of KCl has a concentration of 0.55 molar. Calculate the number of grams in 2,000 centimeters cubed of this. So straight away I'm seeing this, and I'm going to do this conversion as rough work. 2,000 centimeters cubed, 2,000 cm cubed. I want to convert to liters. So centimeters cubed on the bottom, cancelled with those ones. Liters on the top. 1 liter for 1,000 centimeters cubed. When you do this sum, you're going to get 2 liters. All right. So this is 2 liters of solution. All right. So planning out my question here, what do I want to go between? I have a concentration of 0.55 moles per liter. So I'm going to go from moles per liter to calculate the number of grams in 2,000 centimeters cubed. So first of all, before I can calculate the number of grams, I want to find the number of moles. So I'm going from moles per liter to moles in the 2 liters, just moles. And then I'm going to convert that to grams. All right, that's your plan. That's what I'm going to do. The substance is KCl. So working our way through this, this is what I'm going to do. We have 0.55 moles of KCl per liter. And we want to cancel our liters here to get moles. So moles per liter to moles is what we're going here. All right, so we're going to times it by a number of liters. Now, what do we know? We know we've got 2 liters of solution. So 2 liters. So if it's 0.555 moles per liter, thinking this through logically, how many moles should that be if I had 2 liters? Well, it's got to be more, because if this is 0.55 in 1 liter, then it's got to be, think about that, twice as much, 2 liters. So that's what I should be getting here, 0.55 times 2. And the answer I'm getting here equals to 1.1 moles, okay, of KCl. All right, so that's moles of KCl, and now I want to go to grams of KCl. So again, let's pause the video and finish this off. If you were struggling with it, you should be able to finish this now. Of course, we want moles of KCl to cancel, moles of KCl. So we're going to have a conversion factor here, which has moles KCl down here, and they'll cancel with those ones. And we've got grams of KCl on the top, which is what our answer should be in. So whatever we get here is going to be a certain amount of grams of KCl. All right, so what's the relationship for every 1 mole of KCl? How many grams of KCl do we have? Okay, so this here, the mass of potassium is 39, mass of chlorine is 35.5. So maybe your number might have been slightly different from mine if you were using just the rounded number of 35 or 36 for chlorine. I'm using 35.5 because that's the number in the log tables. So when you do those up, 39 plus 35.5, that's giving me 74.5 grams per liter, or per mole. So that's 1.1 times 74.5, and that gives me 81.95. 81.95 grams of KCl. Just double check, is that the answer I got? Yeah, that's the answer I got. So that's what you should have got. All right, we're finally on to looking at a titration calculation. You see all the steps and all the little things you have to be able to do, and there's more as well. I'm just trying to cover the main ones here. All right, so let's see this here. This is the typical reaction we have in an ordinary level titration. All right, so here we see that 2 moles of HCl react with 1 mole of Na2CO3, and it produces these products. What's important in a titration is how do the 2 reactants react with each other. Okay, the first thing I'm noticing here is that I have a 2 moles to 1 mole ratio. Okay. Now, I always ask my students to write down, to draw 2 arrows here and here, and here and here, to put some important information on. Okay. So it says here, hydrochloric acid reacts with the sodium carbonate according to this equation. Sodium carbonate has a concentration of 0.5 moles per liter. Okay, so sodium carbonate is this one here. So I'm going to write that here, 0.5 molar. Each titration, 0.025 liters of this solution. So I'm going to write the volume here, 0.025 liters. Now, in a real titration question, this information will be there, but it wouldn't be as obvious. I'm trying to make this easy for you while you're learning. So I've made it very obvious with what the volume is and what the concentration is. In the real titration questions, you have to dig a bit more for this information. All right, let's see about the HCl then. Here it says 0.19 liters of HCl are required to react with this solution. So the volume of the HCl was 0.019 liters. Okay, and then it's saying to find, eventually we have to find the concentration moles per liter of HCl. So we don't know this, question mark, molar. All right, so it's broken into steps here for you. And these are roughly the steps you would have to do in a titration, but it wouldn't be, they wouldn't be broken into these steps for you. So we're going to build them up step by step. First of all, it says find the number of moles of sodium carbonate used in one titration. Well, what do we know about sodium carbonate? We know the concentration and we know the volume that was used. Okay, and we have to find the number of moles. Okay, so planning this out here, how would we do this? Well, we know we want to convert to moles of Na2CO3. That's what we want our answer to be in, moles of Na2CO3. And we know that we're starting with moles of Na2CO3 per liter. Okay, so we need to get rid of the liters. So we need to cancel out the liters. How would we do that? And obviously that's going to leave us moles of Na2CO3. Yeah. So we want to cancel out the liters. How are we going to do that? Well, obviously to cancel out the liters, I need to multiply by some amount of liters. Okay, which is exactly what I'm going to do here now. All right, so I know that my sodium carbonate is 0.5 moles per liter. And I want liters to cancel. So that means I need to multiply by an amount of liters. Okay, so back up here, how many liters did I use? Well, I used 0.025. So I'm going to multiply by 0.025. Of course, that's going to cancel my liters. And look what I'm left with, moles, which is what I wanted over here. Look, perfect. So equals a certain amount of moles. So I'm going to go ahead, 0.5 times by 0.025. And my answer is 0.125 moles. 0.125 moles, and that, of course, is the Na2CO3. Now it says find the number of moles of HCl this reacted with. This is typically what you have to do during a titration. We know how many moles of Na2CO3 were used in each titration. So we've got moles of Na2CO3, and we want to convert those to moles of HCl. So of course we need to cancel the moles of Na2CO3. So how are we going to do this? Well, let's write down what we know. We know we've got 0.125 moles of Na2CO3. That's what we've calculated in the first little bit. We need those to cancel. So if I want those to cancel, I need them to be in the numerator of this conversion. Moles of Na2CO3 have to be down here, so they cancel. And that means that the other thing, moles of HCl, is going to be in the top, because that's what I need to go to, moles of HCl. All right, so my relationship then, what's my relationship? How many moles of HCl for how many moles of Na2CO3? Well, that's up here in my molar ratio. 2 HCl's for 1 Na2CO3. So I'm going to put 2 HCl's, moles of HCl, for 1 mole of Na2CO3 equals, and now I will get my answer in moles of HCl. So 0.125 times by 2 over 1. My answer here is 0.25 moles. And this is moles of HCl, because that's the unit that's left. And look what I was asked for, find the number of moles of HCl. Now we're asked to find the moles per liter of the HCl. So what I want to do here is go from moles of HCl to moles per liter of HCl. So literally going to put the moles over the number of liters. All right, so how are we going to do this? Well, we need to check the numbers up here. How many liters of HCl did we use? It was 0.019. Okay, and my moles was 0.25. So that's got 0.25 moles of HCl per 0.019 liters of HCl. And of course, that's going to give me a molarity because it's moles per liter. So 0.25 divided by 0.019 gives me an answer, or quite a high number, give me a number of 13.157 or 158 molar. Now that number seems very high. I'm just going to go up and check. Could that be plausible? It seems a little bit too high. So have I done something wrong here? 0.25 divided by or over 0.019. That number just seems very high. I'm just going to have a little investigate here. See, have I done something wrong? Got 0.25 moles. And that was in a volume of All right, so I obviously had my suspicions about that number, and this is a good thing for you guys to see because I've made a mistake somewhere. This actually did not seem right. So I've gone back up here to my line up here, and if you were following along, you may have spotted my mistake up here. When I did 0.5 times 0.025, I don't know what I did wrong. Maybe I just recorded this number wrong, but this number here should have been 0.0125. And that made a big difference to my calculations later on. So that means that it's wrong here as well. So this has to be 0.0125. And then if I times that by 2/1, that means that this number is now 0.025. 0.025 molar HCl. And that means that when I'm down here, that I need to change it in the numerator here as well. It's 0.025. And then I'm going to divide that by 0.019. And my answer is coming in at 1.318 now. And that seems much more plausible. 1.318 molar HCl. Okay, so something's like, I just got very suspicious there about that number being so high compared to the base. The base was only 0.5 molar. That just wasn't adding up. I knew the number was too high. 13 molar was it just didn't seem right. And that's a good sign for you to go and check your work. So it's a good thing for you to see that. All right, let's have a look now at this one again. This is a we do one. Okay, so what I'm going to do is I'm going to get you to pause the video. I'm going to get you to write down this line here, put the 2 arrows in like I did before, there and there. Okay, so write this out and put the two arrows in underneath. Okay, and then picking out the information in this line here and filling it in underneath. Now remember, you want molarities and you want liters. So pausing the video and doing that now. Okay, so here it says the sodium carbonate has a concentration of 0.3 molar. So that's quite easy to see that this has to be 0.3 molar here. And it says 25 cm cubed of this solution was added to the conical flask. So we want that volume, but we need it in liters. So if you wrote 25 here, 25, that's wrong because this is in cm cubed, and I want liters on that arrow. So convert to liters first, do that now. Okay, and you don't be playing if you've converted that to liters, 0.025 liters. Well done. All right, looking at the HCl then, it says 14.5 centimeters cubed of HCl are required to react with this. So let's put in the volume here in liters. Pause the video, convert this to liters of HCl. Okay, so hopefully we've done this 0.0145 liters. And our concentration, our molarity is a question mark. That's what we're going to be trying to find here. Good. All right. So what I want you to do is look in that question 1. It says find the number of moles of sodium carbonate used in one titration. So pause the video and write down the units. How are we planning this out, please? Pause the video and do that now. All right. Well, what we should be doing is going from moles of Na2CO3 per liter to moles of Na2CO3. Okay, so go ahead and do this. What do we need to do? Okay, so you should have this done. Well done if you do have it done and you're confident. But looking at this, I need to go from moles of Na2CO3 per liter to moles of Na2CO3. I need the liters to cancel. So how would I do that using a conversion? Pause the video. Go ahead and do this. Okay, so the information I have is that I have a 0.3 moles of Na2CO3 per liter solution, per liter. And I want to cancel that liter. So I need to multiply by a number of liters to make that cancel. Okay, because it's in the denominator, I need something in the numerator to make it cancel liters in the numerator. Okay, so what liters do I have? The information I have is that I used 0.025, 0.025 liters. Now thinking about what should my number be? Well, I have 0.3 moles for 1 liter. I'm using a lot less than 1 liter. I'm using only 0.025 liters. So I should have a lot less than 0.3 moles. I should have quite a small number in my answer here, just thinking logically. So I need a number of moles of Na2CO3 here as my answer, So pause the video and do the sum on the calculator if you haven't already got this done. The answer I'm getting is 7.5 by 10 to the minus 3. Well done if you got this right. All right, let's find now the number of moles of HCl this reacted with. Pause the video, plan it out, and then pause the video and finish it off. Okay, so planning it out, it's quite simple. I'm going for moles of HCl. Oh, sorry, no, I don't have moles. I have moles of Na2CO3, moles of Na2CO3, and I'm converting that to moles of HCl using my equation. Go ahead and do the calculation. Okay, so remember, you want to cancel moles of Na2CO3 and leave you with moles of HCl. The first thing you need to do is write down how many moles of Na2CO3 we have. We have 7.5 times 10 to the minus 3 moles of Na2CO3. And we want those to cancel. So canceling those units. To do that, we of course need it in the denominator of our fraction, our conversion factor. So I'm putting moles of Na2CO3 here. And those are canceling. And I want to leave moles of HCl on the top. That's what I want to leave uncancelled, mole of HCl. Okay, so from my equation, what do I know about the relationship between moles of HCl and moles of Na2CO3? As you can see here, there's 2 moles of HCl for every 1 mole of Na2CO3. So 2 HCl, 1 Na2CO3. Pause the video now and work out the number of moles of HCl. So as you can see, it's just a times by 2, so the number should be getting bigger here. 7.5 times 10 to the minus 3. And we're multiplying that by 2. The answer I'm getting here is 0.015. 0.015 moles of HCl. All right, and the last one then, find the moles per liter of HCl. Okay, so you've got the moles, find the moles per liter. How are we going to do this? I'm going to just scroll out so you can see the volumes again. Pause the video and plan this out. Okay, so we're going for moles of HCl. And we want to end up with moles per liter of HCl. So you put the moles you have over the liters you have. That's it, very simple. Pause the video and do that now. Okay, so we have 0.015 moles of HCl. Per, we have it in a volume of liters, which is 0.0145. 0.0145, and of course my answer then is going to be in moles per liter or molarity, and I'm getting 0.015 divided by 0.0145, and the answer I'm getting here is 1.034 molar. 1.034. That seems okay comparing it to the sodium carbonate, 0.3 molar. They used a lot less of the acid, and it's 2 to 1, so that kind of makes sense. And it's a good bit higher. All right. And that is how you do that one. Okay, now we're going to do this one together. Now, the only difference about this one is it's not broken into 3 nice, easy steps for you. So the 3 steps kind of stepped your way through it. In this question, we're jumping straight to asking you for number 3. Now, you still have to do all the bits in between. It's just that they're not breaking it down and giving you instructions on how to do it. All right, so we're going to do this one again. Let's have a quick read of it, see what information we have. All right, what we're going to do is we are going to make our 2 arrows here like we always do, rewrite out this formula or this equation with the 2 arrows on it and put the information on it. Pause the video and complete this section now. Okay, so as you can see, 0.11 molar is the sodium carbonate, so 0.11 m. And the volume, it says 25 centimeters cubed of this solution is added to the conical flask. So I need to turn this into liters. Pause the video and do this now. Okay, what you should have got is 0.025 liters. All right, the HCl then, there's information about the HCl. The HCl is here and we require this amount, and that should say cm cubed. So go ahead and find out how many liters that is of the HCl. Okay, so that should be 0.025 actually, do you know what? I'm going to do it on the left-hand arrow here, just for more space. 0.02245 liters. And we have a question mark molarity, because look what it says down here. Find the concentration, moles per liter of the HCl. So that's our unknown. That's what we're trying to find. All right, so what I'm going to do is I'm going to give you an opportunity to pause the video and plan out all the steps here. Okay, you don't have a nice question 1, question 2, question 3, but you still have to do all those bits here. So plan out, what do we need to do? What are we starting with? What do we need to do? Pause the video and make your plan now. All right, so here I'll help you if you're stuck. This is what we know. This is number 1. We're going to use this to go to number 2, find the moles of that. Then we're going to find the moles of this, and then we're going to find the moles per liter of this. Okay. All right. So let's work our way through that now. All right. What we want to do here is step 1, go from moles per liter of Na2CO3 to the number of moles. So we're going to moles of Na2CO3. Used per titration, of course. Moles per titration. We don't have a full liter, we have a titration full, which isn't a full liter. Then that's step 1. Step 2, what's step 2? Pause the video and you take over now. I want you to plan it out to the end. Step 2 is to go from moles of Na2CO3 and convert that to moles of HCl. How much HCl did it react with? Good. Now we're nearly there. Pause the video and finish. What's the last step? Okay, so the next step, number 3, is to go from moles of HCl, which we've just found up here. We want to convert to moles per liter of HCl, or molarity of HCl. What was the volume in liters that it was in? Okay. All right, so well done if you planned this out properly. Let's go ahead and do this sum now. All right, so pause the video and work your way through it. You should be able to get to the end by yourself now. Take away the crutch. Don't be relying on me. All right, so let's work our way through this. Okay, so we're starting with moles per liter of Na2CO3, which was 0.11 moles Na2CO3 per liter. And we want to go to moles of Na2CO3, which of course means we need to cancel our liters. So we're going to times it, liters by liters. Okay, so we'll cancel that. And that means we need to put a number of liters in, which of course was 0.025. 0.025 liters. That'll give us a number of moles. So 0.11 times by 0.025. That gives me 2.75 by 10 to the minus 3. 2.75 by 10 to the minus 3 moles of Na2CO3. That's step 1. Good. Then we want to go for moles of Na2CO3. We want those to cancel and end up with moles of HCl. Okay, so how do we do that? We go, we write down what we have. 2.75 by 10 to the minus 3 moles of Na2CO3 times by, and we want that to cancel. We need this to be gone. Moles of Na2CO3. We're going to put it in the denominator of this fraction. And we want to convert to moles of HCl. So that's in the denominator, means it cancels with this one over here and leaves us with moles of HCl. What's the relationship? As we can see from our equation up here, 1 Na2CO3 for 2 HCl's. So 2 HCl's on the top, 1 Na2CO3. That's going to give us our answer in moles of HCl. So we're going to pause the video and we're going to do that sum now. Okay, the answer I'm getting here is 5.5 by 10 to the minus 3. And this is moles of HCl. The last step that we planned out, we know the moles of HCl. Now we need to find the molarity, moles per liter. So writing out what we know, 5.5 by 10 to the minus 3 moles of HCl. And we want to convert this to units of moles over liters. So we're going to put the moles over liters. Now, what was the amount of liters that we used? It wasn't 1 liter. In our titration, we used this amount of liters of HCl, 0.02245. 0.02245 liters. Okay, so 0.02245 liters. Now, if we had that many moles in a very small amount of liters, then my molarity, how many would I have in 1 liter, should be a lot more than this. So my answer should be a lot more than 5.5 by 10 to the minus 3. And it is. It's 0.2245. 0.245 moles, molar or moles per liter of HCl. Okay, so that is how you do a typical titration calculation up to moles per liter. Now, the extra difficulty in the questions in the exam papers really are that the wording is a little bit more difficult. All right, so what I'm going to do is I am going to ask you to do this one by yourself now. Okay, so pause in the video and working your way through this one completely now. Get rid of the crutch. This is all you, okay? Okay, so you should only be watching if you've finished all the way to moles per liter. As a challenge, let's see, can we now take that moles per liter of HCl and express it in terms of grams per liter? This is sometimes an extra bit that's thrown onto the end, so this is bonus. If you can do this now, good, but we've already done these in some of the earlier ones on the page above, so this should be easy enough now. Okay, let's work our way through this. Okay, so this is the last question, by the way, so you've done really well here if you stuck with it all the way. And this is a really good back to basics opportunity here. Okay, so what do we know? The sodium carbonate is 0.019 molar. 0.19 molar, sorry, not 0.19, 0.19 molar. And we're using 25 centimeters cubed, which is 0.025 liters. For the HCl, we used 12.8 centimeters cubed, which is 0.0128 liters. Okay, so I'm just assuming that you guys know how to do those conversions, and I know that this is a question mark molarity. This is my unknown. Plan this out. What am I going to do? I'm going from moles per liter of Na2CO3. That's my known solution. I'm going to find out how many moles I use per titration. So I'm getting rid of liters, and I'm going to moles per liter. Or just moles, sorry, moles of Na2CO3. It's already in moles per liter. I'm going to times it by the liters I used and get the moles that I have. Then I'm going, in the next step, I'm going to moles of HCl that reacted with, and then I'm going to moles of HCl per liter. So there I'm just taking all the steps that we did and putting them into one line here. All right, so let's go ahead and do that. I know I had 0.19 moles of Na2CO3 per liter. And I'm cancelling my liters because I didn't use a full liter. I'm timesing it by the amount of liters I used, which was 0.025, so 0.025 liters. And of course, liters over liters is gone, which leaves me with moles of Na2CO3, which is what I wanted here. So equals, doing 0.19 times by 0.025, and that gives me 4.75 by 10 to the minus 3. 4.75 by 10 to the minus 3, and that's moles of Na2CO3. So that's got me up to there. Well done. Now I'm going to find out how many moles of HCl that is. So I'm going to take this number of moles, and I'm going to convert it to moles of HCl. So I want this to cancel. So I've got to put it in the denominator of this fraction here. Oh, sorry, I'll keep that line a bit straighter than that. So this is moles of Na2CO3. And I'm going to put moles of HCl on the top. And of course, I know I've already cancelled those. So from my balanced equation, what do I know? I know there's 2 moles of HCl for 1 mole of Na2CO3. So when I do this now, I'm going to get my answer in moles of HCl. So this is 9.5 by 10 to the minus 3. And that's moles of HCl. I'm going to the next line to finish this off. 9.5 by 10 to the minus 3 moles of HCl. Okay, and I need this as a moles per liter. So I've got moles and I want to turn that into moles per liter. So I'm going to go ahead and make a fraction and put moles over liters. Now I didn't use a full liter. How much did I use? I used 0.0128 liters. So 0.0128 liters. This is how many moles was in this many liters. So when I do this then, divided by 0.0128, 0.128, that's given me an answer equal to 0.742 molar. Okay, or moles per liter of HCl per 1 liter. Now, let me just think here for a second. Is this logical? 0.742. I'm looking up here. Well, this was 0.19. So this is quite a lot higher, but it is a 2-to-1 reaction. So it should be at least, at least twice the amount of moles. And then I used a lot less of it. So yeah, it does make sense. Okay. Right. Then I'm taking that one for my next one. I'm taking that many moles per liter and expressing it in terms of grams per liter. Okay, so the plan here is to go from moles per liter of HCl, and I'm converting to grams per liter of HCl. Now, you'll notice that liters is in my first answer and it's still in my second answer. So I don't need to do anything with volume. What I do need to do is go from grams to, from moles to grams. Okay. All right. So if you weren't sure how to do that, maybe this has helped now. So I'm going to go ahead. I'm going to do this 0.742 moles per liter. And I want to leave the liters alone, but I do want to cancel moles and get grams. So I'm going to cancel the moles. So that means in this fraction here, I need moles to be in the bottom. All right, copy this out. What goes on the top here? Pause the video and you finish this. Okay, so if moles is on the bottom, I need grams on the top. Okay, and of course the substance is HCl. Okay, so what I need to do here is find out what's the relationship between moles and grams of HCl. For 1 mole, how many grams of HCl that is it? All right, well, I'm using 35.5 for HCl. That's the number that's in the log tables, plus 1 for the hydrogen, and that's given me 36.5. 36.5 grams for 1 mole of HCl. And now I have a fraction to do. 0.742 times by 36.5 over 1. And the answer I'm getting is 27. Okay, so that gives me 27 grams of HCl, because look at that's the unit that's left. The only unit that's left in the numerator is grams of HCl, and I've got liters in the denominator, the moles are gone. So that's 27 grams of HCl per liter of HCl solution. All right, so that is quite a lot of work that you guys have done here, okay? But it should stand here, okay? So we've gone back to basics. We've really broke back down the calculations. We've built it up slowly, and now you should be ready to go into the set of videos that are in this playlist and work your way through, first of all, the ordinary level exam questions, but after that, then the higher level exam questions on the titrations. That's the aim here. Now, if you're only doing higher ordinary level, then that's fine. You just work to the ordinary level ones, but the higher level students, you obviously need to work your way quickly through the ordinary levels and get onto the higher levels where there's little extra bits. But these are the basic calculations, and hopefully now give you some confidence and get you working your way up. All right, guys, I hope you found this video useful. I hope you lasted till the end, and we'll see it in the next videos where we do some of the exam questions.